Hey, what's up, everyone? Hopefully, you guys have been keeping up with everything that's going on. Most of you guys have seen your work. You're doing great. Um, but this week we are going to take our first test. So, um, kind of going to preview some things here. I'm going to preview, kind of schedule some things out that I want you guys to know. So, schedule. Here we go. I have kept up with this in our Google Calendar. So you guys can see it. All right, Monday we started our review. So hopefully you guys have gone through that review and done as much as you can that you don't have questions on. Hopefully today, tomorrow, I can answer all those questions that you guys have and be prepared for your test. So that's the biggest deal is on Thursday, and you will only have Thursday to take your test on statistics. And when you guys open up that document, you'll have a set time limit. It is mostly multiple choice. There is one free response question, um, but everybody should be taking that test on Thursday. So Monday started the review. Today we are going over review. Wednesday I'm going to add a few more questions. I'm going to go over the rest of it. And hopefully hear from some of you guys to be able to answer your questions, because this is what's going on. All right, so we've been set certain times that we can have meetings. I have set up in the calendar a Google Meet, right? Tuesday, that's today. There's a Google Meet at 10 a.m. Right, the link to that I've put on the Google Classroom. And so all you have to do is click and enter that link. I'll be there and you can ask a few questions. Be logged on at 10 o'clock. Like I said, when we're done, we'll be done. But Tuesday, I'll be available for tutoring 10 a.m. Also, again, on Wednesday, it's the same link. You can go to our Google Meet. We'll be at 11 a.m. is our scheduled time for math. And so please tune in both days, one day, any day, to get any help, any questions answered that you guys may have that you're worried about for Thursday's test. And so as we get started here, once again, I want to make sure you know what to be prepared for. This is going to be our stat test and data. So being able to find central tendencies, that includes mean, median, and mode. And not only just finding mean, median, mode, but using and describing those in context. So central tendencies, we also have spread. So talking about the range of data, IQR, the interquartile range, also looking at mean absolute deviation, be able to find those, be able to use those. There's a few good questions in this review that we're going to talk about that's going to help with IQR MAD. Also need to be able to calculate outlier. And remember, that's taking 1.5 times the IQR and setting boundaries outside to find outliers. As we talk about outliers, we want to talk about skews and how outliers can skew and how data is distributed. And when I say data distribution, I'm talking about whether it's uniformed, bimodal, meaning two mounds, or if it's skewed to the left or to the right, um, or if it's symmetrical, and so forth. So that's the first part of that test. Trying to think what else we're missing. It should be the first part. The second part we've been talking about last week in our videos, but that's two-way tables. Two-way frequency tables. When we say two-way frequency tables, is being able to read and talk about describing this data. We say, hey, X, Y, ZW, whatever it may be, that we're looking at, guys, girls, heights, weights, sports, whatever, and talking about joint frequencies, talking about looking at the totals. Hopefully we paid attention to those videos. Then when we add these totals here in orange, those are marginal frequencies. It's going to kind of make a table here so you guys can read this orange. Marginal frequency, whereas the purple is joint frequency. So how many times that the actual category happens versus the total number, joint versus marginal. Remember this last box down here is the total of all people that participated in that frequency table or all data in that frequency table. And when we start comparing, there's a keyword. Relative. Let's clean that up. Relative frequency means compare to the total. So when I say compare to the total, you're going to create a percentage. So you're going to divide the joint by the marginal. So big part of the test. So let's dive right back into this review sheet I have for you. Going to run through on the first couple pages, and we'll get to the rest of it tomorrow. So Sarah asked 40 randomly selected underclassmen at her high school whether they were planning to go to college and whether they were planning to move out of their parents' house. All right, the results are summarized in this table. And so I'm going to point some things out. One, she has put in what we call joint frequencies. It's how many times those happen. The table's asking us to put in marginal, which means totals. So let's do that for how many people plan to move out? 24. How many people don't plan to move out? Well, 16. One thing we should notice is that when we add those totals up, that should give us our total of 40 people. So the ones that are going to college, that's 28. The ones that aren't going to college, that is 12. Once again, when we add those up, it should be 14. So what percentage of underclassmen plan to move out given that they plan to go to college. So that's a big word here. We have to be able to read and decipher what these questions are asking. So I'm going to use a different color highlighter to highlight some of the things that we need. What percent of underclassmen plan to move out of their house? So underclassmen plan to move out. Well, 24 total plan to move out. But it says given that they are going to college. Well, we need to take away that we're really looking at just 16. So 16 of those underclassmen are going to move out, given that they're going to college. And we need to find the percent. So we're going to divide that by 40. So 16 divided by 40. That's 40% of those students. Cool. So make sure actually you're paying attention to the wording of each question. So the same thing, part B here, same question, same everything. It says of underclassmen that are planning to move out, of underclassmen planning to move out, underclassmen, that should be 24. What percent are also planning to go to college? So now our total changes because we're starting here. We know that they're going to move out. What percent of those are planning to go to college? Well, who's going to college? 16, but we're not going to divide by the total. We're just dividing by those moving out. 24. So go back to our calculator. 16 divided by 24. And we're talking about percents. So I will move that decimal spot 2 places. 67%. Cool. All right, let's keep moving on here. I'm going back to our central tendencies, finding means and medians of our data set. Which measure central tendency best represents the data? Well, I need to look at them. Let's find the mean. Going to roll through our calculator here. I do want to show you guys this. I did last video, but I think it's good practice to do it again. Remember, we're dealing with statistics. If you have a TI-84 calculator, you can use it. I'm going to press stat. I'm going to create a list. So edit my list. In L1, I can enter in all of my data. Two, 7, 30, 21, 22, and 54. All right, so it looks like I got them all in now. And so now that I have it entered in, I can press stat one more time. This time I want to scroll over here to calculate. And we are dealing with one variable statistics. And calculate. So it added all my terms divided by the total number of 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. And so I do have a mean of 18.9. All right, median, my middle term. My calculator does do that for me. Remember that is going to be here between Q1 and Q3. That is a median of 19. And so which data best represents? Tough one. I don't think they're very similar. So when we look at which measure best represents our data, I'm always going to lean towards the mean. Why? Because it's our average of data. And I don't see a real outlier that sticks out. And so our mean is probably going to be the best one. You could make an argument for median, but the biggest thing is you have to have an argument. This is going to be a part of your short answer question, is coming up with a reason of why you chose the central tendency that you did. So keep moving. Find the median of our data set. This time I'm not going to use a calculator for the simple fact that some of you guys are going to have to do it by hand. So the first thing is making sure we order our data from least to greatest. So I have it all ordered. I have 1, 2, 3, 4, 5, 6, 7, 8 terms. So my middle term should be right in between 21 and 23. So if I add those together and divide that by 2, 22 should be my median. So once again, you guys should be able to do that by hand. If I have an even number of terms, remember it's the term in between those two. All right, so now a big one here that is giving some people some trouble. Trying to find the mean absolute deviation. First things first, find the mean. I'm going to use my calculator. I'll calculate it by hand. 12 plus 19 plus 24 plus 37 plus 44. So I have all of my terms entered, 1, 2, 3, 4, 5 different terms. I'm going to divide that total by 5, 27.2. That is my mean. And so remember, mean absolute deviation, how far are each one of those points from the mean? Pull my calculator again. We have 12 minus 27.2. See if we can't do all this together here. I'm going to have to write to the left-hand side. That is okay. I don't care about the negatives. 15.2. Right, so 19 minus 27.2. 8.2. 24 minus 37 minus 44 minus sorry, too many fours. All right, so now that I have the distance of each point from that mean, I now need to find the average of those numbers. So I'll use my calculator, 15.2 plus 8.2 plus 3.2 plus 9.8 plus 16.8. I still should have 1, 2, 3, 4, 5 terms. So take that total divided by 5. I have a mean absolute deviation of 10.64. All right, so there's a rundown again of mean absolute deviation. Hopefully that helps you guys out. If you have to do it on the test, it will be small, just like that one. And here we go, questions 5, 6, 7, and 8. All are kind of pertaining to the box and whisker plot. It's important for us to be able to determine data and read these box and whisker plots and read any graph really. Please make sure you understand how to read bars, graphs, and box and whiskers and frequency tables. That those questions will be on the test as well. But basically, what is the median of a data set? Well, we know the median is the middle term. So in our box and whisker plot, the median should be 62. Right? So we talk about the IQR, the interquartile range. First, we need to be able to find Q1, which is 60. The upper quartile, Q3, is 64. So that should give us an IQR of 64 minus 60, which is 4. And also the range, another spread for us. The least term is 58. The maximum term is 66. So the difference between those two should be 8. So here's a big question though. And make sure we understand what these actual points are doing to our data. It says what percent of data is greater than 64? Remember we cut that data into fourths. And so I'm going to erase some of this so it makes sense. Check this out. So from our least term to our Q1, there's 25% of our data is located right here, right? So between Q1 and halfway, that means there's another 25% of our data. So really, to the left side of our median means there's 50%. So the same thing, to the right side of our median is 50% of our data. And so between the median and Q3, that's another 25%. And so from Q3 all the way to the end, that is 25% of our data. And so when we look at the question, what percent of our data is greater than 64? Well, that's our Q3. So that means that there's only 25% of our data that is greater than 64. And so a good thing to look at here is how those terms actually split up our data. You will be asked questions about that. So stem and leaf plots we haven't talked much about, but remember this is our first. I'm just reading our key. Our stem here is second digit, whereas our leaves, so that would be 0, 3, 0, 4. We have 2 of those 0, 4s, 0, 6, and so forth to read our stem and leaf plot. So what is the mean of our data? Well, the biggest thing is just like we've been doing, let's list all that data out. I'm going to do that real quick by pressing pause. All right, so as you can see, I've listed out all of our data now, and I'm going to use my calculator, or it is in order, so we don't really need to use our calculator. We just need to count how many terms there are. There's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 terms. And so I should have 8 on each side. So if that's 5, 6, 7, 8, so that means, let me change that color. Boom, that should be halfway. So 1, 2, 3, 4, 5, 6, 7, 8 terms greater than that, 8 terms less than that. So what is halfway between 14 and 18. 32 divided by 2 should be 16. We have our median of our data set. Now to find the mean, right, we got to add them up and all divide. So I'm going to pull my calculator up for that. Pause the video here, and so you can see. All right, so as I added up every one of our terms, I have a total of 273. I'm going to divide that by, remember, 16 terms. And so our mean of our data set should be 17.1 if I round that correctly. All right, so the range of the data set, our biggest term was 33. Our smallest term was 3. So the difference between those should be 30. All right, so stem and leaf plots. Cool, moving on, question 12. Now, it's the same thing with a stem and leaf plot. This time we're comparing two different restaurants. And so it's a good way to look of their prices. And so the question does say, use the data to support your answer. Compare the prices of the two restaurants. Well, when I look at restaurant A, I can see it's got meals that are 8, 9, 9, 9, 10, 11, 11, 12, 15, 15, 17, 17. And I start comparing. The cheapest meal at restaurant B is $10, right? The most expensive is 25. When I start comparing this data, I'm going to say meals at restaurant A tend to be cheaper than restaurant B. And I also, when I look at that, we have a range 21 to 9. It's a range of 12, which 10 to 25. The range is very similar, so I really think that that's a good statement about these two restaurants. All right, last couple questions today before tomorrow we'll save the rest. All right, the ages of people attending an opening reception for a theater production are listed below. We're going to use this to make a frequency table. Frequency table goes into our histogram. So let's just make some tally marks here. At first, 54, 25, 28, 64, 30, 42, 33, 50, 27, 35, 40, 39, 41, 52, 49, 48, 56, 60, 58, 37, 56, 45, 57, and 62. So I'm going to go ahead and write these out as numbers. I had 3, 5, 6, 7, and 3. So to make a histogram, we will tally 1, 2, 3, 4, 5, 6, 7. And we had 1 age group, 2 age groups, 3 age groups, 4, and 5. So remember, that was up to 29. That was up to 39. That goes up to 49, 59, and 69. So 3, 5, 6, and 3. Just go ahead and write these numbers. Boom. Histogram. Cool. All right, so one last question we're going to talk about today is this: what type of graph would best be displayed? The change in number of student absences over a school year. And if I'm looking at the change and I want to look over a time period, I don't think a circle graph is going to show that, not a pie chart. That wouldn't be good. A bar graph might work, but it really just shows categories. Same with a double. We're not comparing different students. We're just looking at one student and their absences. I think if we showed that in a line graph, we would see attendance and absences. That's over time. Line graph would be good. All right, let's keep going. Bar graph, identify how many candies are yellow and green. So how many green do we have? We have 10 green. How many yellow? We have 4. So how many are yellow and green? 14. Just being able to read graphs. All right, so we're going to stop right here and creating these box and Western plots tomorrow. If you have any questions, please reach out. Remember that Google meeting today. Uh, feel free to join in. We can all talk, discuss, see each other. Same thing with Wednesday. All right, see you guys.